So in this video, I just want to quickly set up the problem of how we can take a ternary or triangular plot and trick Excel into making that kind of plot using Excel's XY scatter plot. So what we're going to do is this. Let's say we have a triangular diagram where we have three components, A, B, and C, where A is bottom left, C is top, and B is at the right. So in Excel, Excel doesn't know how to make these kinds of plots. Instead, what Excel does is it makes scatter plots where we have an X horizontal axis and a Y vertical axis. So what we want to do is translate points that fall into the triangle based on, let's say, things where A plus B plus C is equal to 1 or 100%. We want to translate those into XY coordinates. And the way we do that, if we set up our diagram like this, where C is equal to the height on this diagram, then as you can see, one equation that works very well to at least get part of this diagram is simply let Y equal to C. But what about the horizontal component? Well, a little bit of trigonometry, which we're going to skip, we'll skip over the proof, would be this, to get the horizontal distance. So the Y distance is easy. So the distance Y is going to be equal to C. The X component, or the X axis, will be this. We'll take the value of B, divide it by the cosine of 30 degrees, and then add to that C times the tangent of 30 degrees. And so for fun, you might want to try doing a little bit of a trigonometric proof to show that that's the case. So what will this get you? So here we're taking B, this is two terms, B divided by cosine 30 plus C times the tangent of 30. This will give you the x-axis that will allow, let's say, this point here, where we have a sum of A, B, and C values that'll translate now into an xy coordinate. So clear the chalkboard. If we have values of A, B, and C, and then we want to convert them to x and y coordinates, here's what they would look like. So let's say you've got something that is 100% A, 0% B, 0% C, and then another thing that is 100% B, and another thing that is 100% C. You'd want to plot these points in Excel because those are your endpoints, and then you can use some drawing functions or import them into an Illustrator program of some type to draw the edges of the triangle. Well, the xy coordinates would be this if we do the translation that we showed earlier. The A, since it's the lower left part of the triangle, then that would be the coordinates of x equals 0 and y is equal to 0. For the case of something that is 100% B, that would end up at about 1.1547 on the x-axis and 0 on the y. Remember, B is down here, so no vertical component there. So that's A, that's B, and that's C. This is y going up and x to the right. And then for something that is 100% C, it would be 1 on the y-axis, and then half of this x value, so 0.57735 or so. Now be careful when you enter Excel, when you enter the cosine of 30 degrees, this should actually be in radians. So if you're writing this in Excel, you might want to write cosine and then radians 30, and then close parentheses when you enter the cosine. And the same for the tangent. For the tangent function, you'll want to write tangent, and then radians, and then 30, and then close the parentheses on both of those functions. Because Excel by default is going to read this entry as radians, not as degrees, in the way I've shown you in the proof that we've developed here. Or that I'm not really showing you. This is in degrees, not radians. In radians, it's about a little over 0.5 or so, but you'll get a more precise value if you insert the radians function. I will do another example in Excel itself, but these are the basic equations and how they work to translate triangular components A, B, and C into XY coordinates that can be plotted in the XY scatterplot function in Excel.